You are looking at the most dangerous thing in this solar system, not because it is violent, not because it is unstable, but because it looks completely, utterly harmless, and it has been hiding something beneath its surface for 4 billion years that we are only now beginning to understand. There is an ocean on this moon, real, liquid, saltwater sealed under miles of ice, in total darkness, cut off from everything above it for longer than complex life has existed on Earth. We've never touched it, never seen it, never sent anything in, and yet the science keeps pointing toward the same conclusion over and over in ways that are becoming increasingly difficult to explain away. Something may already be living inside it, not as a guess, not as a hope, as a logical outcome of everything we know about chemistry, heat, water, and time. Europa does not look terrifying. It looks smooth, quiet, almost beautiful, pale as polished bone, drifting silently in Jupiter's shadow. But the most dangerous places rarely announce themselves, and the closer we look at this moon, the harder it becomes to explain why it should be empty. From space, Europa looks almost gentle, one of the smoothest objects in the entire solar system, a pale white sphere wrapped in faint orange lines, drifting silently against the dark. No towering mountains, no deep craters, no obvious violence written into its face. It looks like somewhere you could land, but you cannot. The surface temperature sits at around -320 degrees Fahrenheit, not cold the way a winter night is cold, cold enough to make steel brittle, cold enough to shatter rubber, cold enough that unprotected human tissue would not freeze, it would fracture. And the ice is not soft, it is compressed, ancient, hard as granite. Those faint orange lines you saw from space are ridges up close, some stretching thousands of miles, walls rising several hundred feet high, glinting faintly under Jupiter's pale reflected light. They formed because the ice beneath constantly shifts, cracks, and refreezes. The surface is not stable. It is a slow-motion collision zone that has never stopped moving. But here is what those cracks are actually telling you. The orange staining along every fracture line comes from salt compounds and sulfur, material drawn upward from the ocean below. The ocean is not passive. It is actively communicating with the surface, sending material upward through the ice, leaving chemical fingerprints on everything it contacts. The surface of Europa is not a barrier. It is a membrane, and something on the other side has been pressing against it for longer than our species has existed. But before you ever reach that surface, before your spacecraft even enters orbit, something invisible is already moving to kill you. Most people picture Europa's danger as cold, as emptiness, as distance. They are wrong. The real threat arrives before you land. It starts working before you have time to react, and it does not stop. Jupiter is not just a large planet. It is one of the most magnetically violent environments in the inner solar system. It rotates once every 10 hours, faster than any other planet, and that spin generates a magnetic field more than 20,000 times stronger than Earth's. This field acts as a particle trap, capturing high-energy radiation from the solar wind, accelerating those particles to near relativistic speeds and flinging them outward in every direction. Europa orbits directly inside this firing range. Picture it this way. Particles slice through the vacuum like invisible hailstones, shredding molecules as they go. They slam the surface relentlessly, tearing apart molecular bonds, frying circuits, baking ice into oxygen compounds, every second, without interruption, without mercy, without end. You cannot see it, you cannot feel it arriving, but it is already happening the moment you enter Jupiter's system, long before the ground is beneath your feet. The radiation dose at Europa's surface runs approximately 540 rem per day. A human exposed to 500 rem over a short period has roughly a 50% chance of dying within 30 days, even with full medical treatment. Europa delivers that dose to every unshielded surface every single day, like a pressure that never once releases. So the obvious solution is shielding. Build thicker walls, protect the electronics, protect the crew. But shielding adds mass. Mass requires more fuel to decelerate at Jupiter. More fuel means a heavier vehicle. A heavier vehicle requires more shielding to protect the additional systems needed to carry it. Every solution creates the exact problem it was trying to solve. The damage does not arrive all at once, it accumulates. Cameras fill with noise over weeks, solar panels degrade over months, circuits collect errors so gradually that by the time you notice the mission unraveling, it has already been unraveling for a long time. No warning, just slow, compounding erosion of everything you brought with you. But here is what makes this genuinely strange. That same radiation destroying everything on the surface is breaking water ice apart into oxygen and hydrogen. It has been doing this for billions of years, and through slow connective processes in the ice shell, some of that oxygen may be working its way downward, delivered into the ocean below like a chemical lifeline sent from above. The thing that would kill you on the surface may be feeding whatever is living beneath it. So what is actually in that ocean? And why does its age change everything about what we should expect to find? Europa sits approximately 390.2 million miles from the Sun. At that distance, liquid water should be physically impossible. The solar heat is far too weak. By every straightforward calculation, Europa should be frozen solid all the way through. It is not, and the reason it is not is one of the most violent geological processes in the solar system, happening in complete silence, invisible from the outside. In the 1990s, NASA's Galileo spacecraft flew past Europa carrying a magnetometer. What it detected rewrote the conversation. Europa was generating its own secondary magnetic field, pushing back against Jupiter's. This only happens one way: when an electrically conductive fluid moves through a pre-existing magnetic field. Solid ice does not conduct electricity, rock does not, salt water does. The data pointed to one conclusion: a global ocean of liquid, salty water, not in isolated pockets, but encircling the entire moon beneath an ice shell estimated between 10 and 30 kilometers thick. That ocean is believed to run roughly 62.40 miles deep. Earth's Mariana Trench reaches about 6.84 miles. Europa's ocean is nearly 10 times deeper and it wraps around the entire world. The total volume of liquid water likely exceeds all of Earth's oceans combined. But liquid water requires heat. The Sun is not providing it. Europa orbits Jupiter in a slightly elliptical path, and because it travels alongside two other massive moons, Io and Ganymede, their gravitational pulls constantly compete. Europa gets stretched and compressed, not as a metaphor, physically. The entire moon flexes on a rhythm. Its rocky interior deforms. That mechanical stress generates friction. That friction generates heat. It has been running this way, without interruption, for over 4 billion years. At the sea floor, where the ocean meets the rocky mantle, that heat almost certainly produces hydrothermal vents, fractures in the crust releasing superheated, mineral-rich fluid upward into the water column. Ocean currents pressing silently against the ice ceiling above, patient and relentless, carrying heat and chemistry through a world that has never once seen sunlight. On Earth, we call these structures black smokers, and on Earth, every single time we find them, in crushing pressure, in complete darkness, no photosynthesis, no sunlight, no surface connection, we find life. Not traces of life, living ecosystems, tube worms, shrimp, crabs, bacteria mats, entire communities of organisms that built their biology around chemical energy rather than solar energy, thriving in conditions we once called impossible. Europa may have those same conditions. It has had them, without interruption, for 4 billion years. The ocean is vast, ancient, chemically active, and thermally stable. But here is the question no one wants to sit with. What does 4 billion years of uninterrupted darkness actually produce? This is the part most discussions of Europa quietly step around. We tend to imagine whatever might live in that ocean as microbial. Small, simple, single-celled. We default to smallness because smallness is manageable, comfortable, easy to file away and not think about again. But Earth's hydrothermal vent ecosystems are not microbial. They are layered and complex, predators and prey, organisms specialized for different depths, different chemical gradients, different pressure zones, and those ecosystems developed in environments that were regularly disrupted. Plate tectonics, asteroid impacts, ice ages, continents tearing apart, destroying established habitats, forcing life to rebuild from scratch, over and over again. Europa's ocean has had none of that. No asteroid reaches the seafloor through 10 to 18.64 miles of ice. No ice age penetrates the chemistry below. No geological reset clears what has been built and forces it to start over. The environment is sealed, pressurized, firmly stable, and it has been that way for longer than complex multicellular life has existed on Earth. We do not have a model for what that produces. Every framework we use to think about life is built on Earth's history, a history defined by disruption, extinction, and rebuilding. Europa may represent something our models were never designed to account for, an ecosystem that was never once reset. And there is one more layer. Models suggest that radiation-generated oxidants at the surface, oxygen compounds produced by Jupiter's particle bombardment, are gradually delivered downward into the ocean through connective cycling in the ice. If that process is efficient enough, Europa's ocean may not be oxygen poor at all. It may be chemically rich enough to support not just the slow metabolism of bacteria, but the faster, more demanding chemistry of organisms that move, hunt, and sense. Heat, minerals, possible oxygen, chemical gradients, 4 billion years of unbroken stability. We are not describing an environment hostile to life. We are describing one that may be more patient, more stable, and more chemically generous than the ocean where life first appeared on Earth. And we have never sent a single instrument into it. NASA's Europa Clipper launched in October 2024. It is in space right now, moving toward Jupiter. It arrives in 2030, where it will conduct nearly 50 close flybys, scanning the ice with radar, analyzing water plumes erupting into space, mapping chemical signatures on the surface in detail never achieved before. It will not land, it will not drill, it will not touch the ocean, but it will look closer than anything ever has. And what it finds, or does not find, closes a door that cannot be reopened. If it returns nothing, no organics, no biological markers, no chemistry pointing toward life, then we are left with a conclusion that is genuinely difficult to sit with. An ocean larger than Earth's, with heat, with chemistry, with 4 billion years of uninterrupted time, and still nothing. That would mean life on Earth was not inevitable, that the conditions that created us were not sufficient on their own, that the universe, for all its size, is far emptier than it has any right to be. But if it finds something, anything at all, then the opposite locks permanently in place. Life did not require our exact star, our exact distance, our exact conditions. Life is something the universe does quietly, in the dark, given enough time and the right chemistry. Which means the hundreds of ocean worlds already identified across this galaxy are not empty. They are simply waiting, and we have never been alone. Not once, not for a single moment of our entire existence. Both answers are irreversible. The ocean has waited longer than we have existed. It does not care which answer we find. It has been sitting beneath its ice in perfect silence, patient, pressurized, and completely indifferent to us, since before the first complex creature moved through Earth's oceans. The question is not whether we can find the answer. The question is whether we are ready for what we find, because once we do, we cannot unsee it, unhear it, or undo it. The discovery does not stay in a laboratory. It rewrites every assumption we have ever made about what this universe is and what we are inside it. Europa keeps spinning in the dark. The ice holds, and beneath it, something or nothing has been there the entire time, waiting, and whatever has evolved beneath that ice has done so without notice, without care, perfectly indifferent to us.